All right, now we're going to do the second free response from review day 1. It gives us a table, and the table has the f prime values at 0 through 6, and we're told that the initial value of f is 20, and that the derivative is always between 0 and 7, so it never spikes up anywhere. It might be going up and down, but it's never going to get above 7 as long as it's in between here. Okay? And we're continuous and all that other stuff. So use a midpoint Riemann sum, 3 subintervals, to find f of 6. Now you gotta be a little careful here. You can do the midpoint sum and get the right answer, but only get one of the 3 points that are available here, because what you're really trying to get is the value of f of 6. You're told an initial value at 0, and we want to go to 6. So in other words, f of 6 will equal your initial value, 20, plus the integral from that time, which was 0, to the time that we want to go of the rate of change, which is f prime. So you need to have this in your head, and if you had this written down on your paper somewhere, or that at least idea, you got a point. Now, what we're going to do then is use the midpoint sum to approximate this. So we're going to say that this is roughly 20 plus, and then we're going to do our midpoint sum. So now, in between here, what we really need to kind of see, it might again help if you draw this out. We're going 0 to 2, 2 to 4, 4 to 6. And in between these subintervals, we're going to use the midpoint. So between 0 and 2, we're going to use 1. So that means we're going to have a height of 3.5, a length of 2. So that gives us an area of 7. For 2 to 4, we're going to use the 3, which is 0.8. 0.8 times 2 is 1.6. And then between 4 and 6, we're going to use the 5, which is 5.8. And if you double 5.8, you get 11.6. All right? Then we're going to add those together. So it's going to be 7 plus 1.6 plus 11.6. And again, you may want to actually show it as 2 times 3.5 plus 2 times 0.8. You know, if you want to just make sure the grader knows where those numbers came from. Whatever the case, we're going to get 12, 13.2, 20.2 here, plus the 20 gives us 40.2 as our answer. So you would get a point for showing the midpoint here, and then you get a point for that final answer there. Okay, I have a feeling that if you showed that you understood how to do a midpoint, but you maybe messed up one of these numbers, you could get this point, but not that point. I think it's 2 if you got it all together. Okay, determine whether the actual value of f of 6 could be 70. Now, a question like this can kind of be confusing. Like, how the heck would I know whether it could or couldn't? It comes back to right here. Our derivative cannot be greater than 7. So since f prime of x has to be less than or equal to 7, the integral from 0 to 6 of f prime dx has to be less than or equal. So let's just think about that. If the derivative is always less than 7, then at its maximum, let's say it was 7 the whole time, just pretend, from 0 to 6 we had a derivative that was constantly 7. So we were growing at a rate of 7 for the whole span of this time. Then our total growth would be 6 times that rate of 7. It would be 42. So what we're saying is that that integral, the sum of the difference, the rate of, or the amount of change that we have, has to be less than or equal to 42, 6 times the maximum 7. So therefore, f of 6 has to be less than or equal to what it started at, 20, plus 42, which is 62. So actually the highest value we could have on this would be 62. So no, f of 6 cannot equal 70. That's too much. 62 is the max here. What did they do that year? They gave you a point for having something like this. It doesn't have to be exactly that, but something that explains that 42 is the largest we could have there, and then a point for this final conclusion connecting it to the 20 and why this is our maximum, not 70. All right. So a strange one, definitely could have thrown you off for sure. C is probably the easiest of the four. It says evaluate this. So when you integrate the second derivative, you go back to the first derivative. So the integral of f double prime is f prime. And using fundamental theorem, we're going to do from 2 to 4, which means we're going to have f prime 4 minus f prime 2. And f prime of 4 is 1.7. And f prime 2 is 2. And we get 2 minus, or 1.7 minus 2, which is a negative 0.3. You got 1 point for showing this, and then 1 point for your answer. All right. And then the final one asks for the limit as x approaches 0 of this. And so what you always do with the limit is plug the value in. So we're going to do f of 0, which we were told up here was 20, minus 20 times e to the 0, which is 1. So 20 minus 20 over half of f of 0, that's 10, minus 10. We get 0 over 0. So anytime we get 0 over 0, that's an indeterminate form. Means we got more work to do, right? It doesn't tell us really anything. So the work we're going to do is L'Hopital's rule. And we can just write it. The grader knows what's going on. What we do is we take the derivative of this. So the derivative of f is f prime minus 20 times the derivative of e to the x, which is still e to the x, over 0.5 times the derivative of f, which is f prime, and then minus the derivative of 10, which is 0. And then L'Hopital says, now try it again, see if it works this time. So f prime 0 is 4 minus 20 times 1, which is 20, over 0.5 times f prime 0, so that's 2. We get a negative 16 divided by 2, which is negative 8. So you got a point for showing L'Hopital's rule, so I believe that this would be part of it. You have to show why you're using L'Hopital's rule, and then you got a point for this answer. All right, so 9 points, 1 point for this fundamental theorem idea, 1 point for the midpoint sum, 1 point for the final answer, 1 point for showing that the integral couldn't be more than 42 between 0 and 6, 1 point for the conclusion, no, we can't be equal to 70 because 62 is the highest we could be. 1 point for integrating the second derivative into the first derivative from 2 to 4. 1 point for correctly getting to negative 0.3. 1 point for L'Hopital's rule. And then 1 point for the final answer.